Sure, Akash.
So yeah, you might be aware that our nervous system plays a crucial role for a human very much, and similarly, it also plays a very crucial role even for the machines to be running very accurately and efficiently. So we'll be talking about the nervous system, that is APIs, and the backend. How does it run, and how does it manage APIs for efficient running of the application, right? So here, APIs are the nervous system of the modern software, right? In order to either add the data or delete the data and any operation to be committed within an application, APIs are the main points which are dealing with the operations, right? And enabling independent systems to coordinate, exchange data, and scale, right? APIs are always enabling independent systems to coordinate, exchange data, and scale, right? We'll be moving ahead, getting deep into the concepts. The contact between two systems. Suppose you're going to a shop and you're trying to buy something. So there, assuming that buying is an operation, then it is always between the shopkeeper and the customer, right? So in that process, the product, whatever you're trying to buy, is reaching you and reaching from the shopkeeper. In that sense, even in the technical world, if the caller or the user who is trying to log into the website and trying to visit the website, he does it from the front end first and then reaches to the server. So we'll deeply dive into the process. How does it happen? So suppose a user enters into the website, then he will first insert a request that okay, I'm logged into the website. Please allow me. In that sense, he requests a specific action or data. Then it moves to the interface, that is API, that acts as an intermediary in between. It is a strict rulebook defining protocol, format, and limits. So the API acts as intermediary that either he has to be allowed or not, as well, whether he is permitted to perform any operations or not, in that sense. And here the methods might be get, put, post, delete, and all, right? And then after the interface deals with the user and allows him to perform operations, then the data is sent to the server, right? Then the data that is executes the logic and returns the structured response. So here, this is a process usually happening between the caller, that is client, that is user from the front end side, and the API as an intermediary, and the server, that is a backend, uh, that is as a provider side in a realistic sense. Please more, yeah. The anatomy of a digital payload. We will understand what is the backbone of digital payload here, right? What are the main components, including to perform as a digital payload as an individual. The first component is the address. In our realistic sense, the address of someone might be the pin code or something else for a realistic sense. But coming to web application, the address of the application is either the URL or the IP, right? The URL is the link that you are clicking on and you are entering into website. That is either you are trying to enter into the Amazon website, then it is Amazon.com, and if you're trying to place some orders, then it moves to the Amazon.com/orders. Orders is the page in the Amazon website, right? In that sense, that is URL. And IP, it is a numerical address of the website. Suppose you have a geographical location or geographical URL such that it tracks your location. Suppose you are sending your a location through Google Maps and all. There, it shows your pin code as well your address, geographical address. In that sense, similarly, it is the same for web application also, right? And then coming to the shipping manifest, that is headers. Headers are playing a crucial role by sharing the metadata. Now you might wonder what is metadata? The metadata is something including authorization tokens. Like after the user is granted an authorization, then the tokens are released. which are called as authorization tokens. So the metadata includes authorization tokens and then the content type, that is details of the user whoever has logged in. So this is about the headers. And then coming to the cargo, that is body, the body always includes the crucial details of a user. Suppose he has ordered an product, then the product ID is stored into the JSON format. That is into the body. Product ID 987 suppose. And then if he is ordering or putting an order for two quantities, then quantity is two. That is again another detail, right? Coming into the body section. So it is always the JSON format, right? That is also you can assume it to be a schema, type of a schema. And then coming to the delivery instructions, that is method. Suppose you are placing an order, then that has to be added to the website. For that operation, we'll be using the post method. And if you want to trace or track how many orders or how many deliveries are kept on the website, then you will trace it through get method. In similar way, we have multiple methods existing in this methodology. You might also look here and try to understand APIs are structured data packets traversing transport layers. Every request carries its own context, authentication, and payload, right? And also, if you want to understand it in a realistical sense, the address is suppose imagine a situation you're trying to buy something and you're getting into the Amazon website, then you will first place your address where you are and where the delivery boy has to come up, right? So the address and then shipping manifest, like from where is the product being shipped and to whom it should be reaching. Then the cargo in the sense details like where it has to be placed, and then the delivery instructions like I want so and so, please place it here, please reach out to the place and all. So this is the realistic scenario of the digital payload. Please move ahead on. Yeah, the language of the network. Suppose the delivery boy is reaching out to you through a signal, right? Traffic signal, and then he has to understand the status codes. In a sense, he has to understand whether it's a green signal, red signal, yellow signal, or what I have to do at what situation and all. So in that sense, even in a technical world, we have the same way the intent or HTTP works. That is, the methods that are utilized in order to place something or in order to retrieve something, in order to delete something and all. So the methods that are including are get method, post method, put, patch, and delete method. The get method is used to either retrieve or read the data, and then post is used to create the data if it is not existing at all, and then put is used to replace existing data. Like suppose if it is already existing and you want to update it with some other value, then it could be done using put method. And come to patch. Patch is used to partially update the data, right? And then delete. If you want the value to be deleted or the data to be deleted, then it is done using delete method. That is to remove. And suppose you have performed one of the operation and you're willing to know whether it is successfully implemented or not. In that case, these status codes are mainly utilized, right? These outcomes or status codes are mainly utilized. The status codes are mainly used to signify whether an operation is implemented properly, successfully or not, right? It shows the status of the operation. And here are some of the status codes which are mainly utilized and which are important to be understood for any user from the core part of the website, not from the utilization part. So you can understand for a suppose some of the status codes are 200, that signifies that an operation is successfully implemented, and 201 it signifies that some value is initially created, and then 204 it signifies that there is no content existing right now, it has to be created rather. So 200, 201, and 204 are the status codes or numerical codes that represent that some operation has been performed and there is the outcome coming up. And then there are also status codes that are shown at the client side also. Suppose you are a user and you are performing some operation on the client side, that is print end, and you are willing to know whether it's implemented properly or not. For that sense, some of the status codes are 400. Suppose you are placing a request at the client side and the request is not sent to the backend at all, right? Then it shows 400 error. That is, the request is very bad. It is not reaching to the backend, right? And then comes 401. Suppose you are placing a request and you are not authorized at all, and then that request doesn't reach out the backend at all. So it states that the 401 status code actually states that no, he is not allowed to place any operation or method, so he is not unauthorized at all. And then coming to 404, if you are trying to retrieve something, retrieve some data from the backend and upon the front end side, then the status code 404 signifies that the data is not existing in the database at all. So it simply shows 404 error, right? And then coming to server side status codes. Suppose similarly you are trying to store some data, but the space of the database is already occupied. There is no more data or no more space existing, and you see that the space is already occupied. And in order to signify that, the 500 code is actually displayed on the backend side. And then 502 bad gateway. If you are trying to retrieve something from the backend, but it is not accepted by the front end, then that's a bad gateway. Then 502 502 code is displayed over there. And then comes to 503, and you're trying to retrieve some data from the backend, and the data is not at all existing in the backend at all. Then there's no meaning of retrieving actually. So in that sense, 503 code is displayed over there. Please move ahead, Pawan. Right. So in order to communicate, even it might be WhatsApp or Facebook or any chat places or chat applications, then the communication standards play a crucial role, right? So here we'll be understanding what are the communication standards involved in either handling with the data or even in the communication process. The first one is REST. REST, you might have heard, it is similar to REST APIs, right? So while performing the methods like put, post, delete, and all, the REST APIs play a crucial role, right? And so they are always resource based and they are stateless HTTP verbs. That is, they are related to HTTP, hypertext transfer protocol, and you might find them to be standard web APIs. That is, example, get users 123. Then that operation retrieves all the data about the users, their respective IDs and all. And coming to GraphQL, that is another communication standard, right? So that is mainly used to ask directly, right? If you are trying to get some data, but without any delay or without any latency, you can get it directly. So it eliminates overfetching. Suppose you're trying to search some object at your home or search some product at your home, then you will have to try searching a lot if it is over busy. But if it is very clean and if it is not very far from you and you have organized it already, then getting that product is very simple, right? So you need not fetch to the uh, entire space around you, and you need not search a lot. So the GraphQL lets you ask directly and lets you fetch the product directly without overfetching. It is helpful in complex front ends needing nested data. The next standard coming up is gRPC. gRPC, it includes a protocol, that is binary protocol, which is also called as protocol buffer, right? And that enables the strong typing and ultra fast. That is, it enables you to communicate very easily, very fast, and without any latency. And it includes the internal microservices communication. That is, enables internal microservices communication. And then comes WebSockets. The very popular part of the communication standard is that WebSockets, which is very frequently implemented in the communication spaces or applications. And this is very persistent and it enables bidirectional open communication. Suppose there's an user coming from the front end side, as well there is another user coming from the other application from the front end side. Then in order to communicate between both of them, it's a bidirectional open connection, right? That is, suppose an user coming from point A and there's another user coming from point B. If both have to communicate, then it has to be bidirectional, not a single direction. If it is single direction, then either point A, the person at point A can communicate directly with point B, but point B cannot respond, might not respond. So it has to be bidirectional open communication or open connection. So this is implemented usually in real-time chat applications or even live trading. Please move ahead on. The memory footprint, stateless versus stateful. You might be learning about stateless versus stateful in the APIs concept or also in the concept of authentication. What is the difference between stateless and stateful? Let's understand here. In the stateful process, like if you are trying to log into a website and your credentials are stored somewhere in a session, right? Your credentials are always stored in a form of a session, and you are giving a session ID in order to recognize easily, right? You are given a session ID, and each session is again stored in a session memory, right? Server stores all of these sessions into a session memory so as to retain them. And if you are trying to log in, then it has to validate whether you are an existing user or not. So for that sense, if the session is stored in the RAM, that is in your laptop RAM, then it is very easy to validate by checking with the RAM and all. But what if it is a database and all? It is very difficult. So this is all about stateful, that your credentials are stored in a session and calling it to be a session memory where there are many sessions. So server retains all of them and it validates whether you are an existing user or a new user. If you are an existing user, then it just validates. But if you are a new user, then it creates a token and releases into the application, that is backend side, so as to store that you're an existing you're a new user coming up. So it enables faster initial interactions but fundamentally bottleneck scaling, right? And then coming to stateless, here the HTTP doesn't validate at all. It's very simple. It doesn't validate at all. Whatever request is coming up to the HTTP, that is hypertext transfer protocol, it treats each and every request to be unique, right? It doesn't treat that it is already done, it is already coming up and it's already existing. Rather it treats every request to be unique and allows each and every request to move into the backend, right? So zero server memory is required, like like we have stored in the sessions earlier in a stateful manner, but here there is no space, no storage at all in the stateless. Zero server memory is required here, and it enables infinite horizontal scaling. Please move ahead on. Right. The life cycle of a production request. Now, we will try to understand after a user logs to the website and how does he handle or what process does he undergo? Right. I mean, what process does he request undergo on the user, like from the client side to the server side? We'll try to understand how does it happen. Right. Now, trying to assume the user has entered into the website through his credentials, then a request is sent from the user side, that is front end side. It is first reaching out to the CDN, that is content delivery network. Then this content delivery network catches it, catches in the sense CACHES, catches it. That means stores it into the memory that this is the request coming from the user side and all. And if it is on a RAM side, I mean, if it is on the laptop RAM, then it is very good. If it is on the database side, then it is I mean, a bit distance, like maintaining a distance. Then might be in order to validate the user whether he's existing or not. It might be a bit difficult, right? So in that way, a CDN, the request enters to the CDN, and then it moves to the load balancer. Why load balance? What is the role of load balancer here? Right. Similar to you, if suppose there are many users entering into the website, suppose there's a lot of traffic, as like we have traffic on the roads and all, in order to manage them, we have traffic signals. But what if it has to be done in the website? Then here comes the role of load balancer. It manages the traffic by distributing them into different servers. Right. You might see here the traffic cop distributing load, and then it moves to the API gateway. Suppose you have crossed the signal and you have reached out to your school or hostel, wherever it might be, and then mm, the school watchman or someone near the gate has to verify that okay, you are part of the organization and you are to be allowed into the organization, right? And then you have to be authenticated first. Then it verifies that okay, you are an existing user, you can go in. So the API gateway acts as a watchman over there or at a gate place and authenticates you and also looks at the number of requests you have sent in order to make any operations in the website, right? And then it moves to the microservice. Microservice in the sense, suppose you are having a database for the website for either a website developed by your side or website developed by someone. If you just paste into the database, you will find multiple collections. That is user collection. If it is a um, customer side also, you will have a customer collection and many collections in the MongoDB or any database it might be. If it is a NoSQL database, then you call out them to be collections, and if it is an SQL database, then it's completely different, right? So microservice in the sense many collections. Then the logic is executed into that collection, and then most of the database, that is data is stored or retrieved easily. So this is what the life cycle of a production request. How does a request from the client side reaches to the database? How is it validated? How is it performing the operations? And how are they accepted and all? Entire process lies here actually. So you might read here, real systems are never a single server. In the sense, the systems are never dealt with a single server. A request traverses, that means travels, multiple distinct layers of infrastructure before logic is ever executed. Right? Please move ahead on. Decoupling systems with message queues. We will understand what is the difference between synchronous, asynchronous, what is the need of synchronous and asynchronous here. Suppose you are moving it to a monument or a very popular monument, and you are trying to book a ticket from there at an offline place, and you're standing in a queue, and suppose the friend person whoever is standing in front of you has to take the ticket, and then you are allowed to take the ticket, right? So in that place, you are allowed to wait for the other person to take the ticket, and then you will be getting the ticket on your own. That is one completely synchronous process. That is, while a process is enabled from the backend side, if already a process is being executed, right, then your process, what you have enabled just now, has to wait until the other process which is being executed to be completed. So that is all about synchronous. And then coming to asynchronous, it is very different to synchronous. That if you are executing a process A and there's another process B, process C, and all the processes could be executed similarly, simultaneously, in a parallel way, in a parallel manner actually. So that a lot of time is not consumed and processes are executed parallelly, and it's an easy execution. Right. I repeat again, synchronous is having process A, process B, process C, process D, and all. You will have to wait for process A to be completed first, and then process B could be executed. And similarly, process B has to be completed, and then process C would be executed. In that way, waiting has to be done in the synchronous process. But in the asynchronous method, all the processes are executed simultaneously, having no need of waiting at all, and low time is consumed actually. You can read out here: asynchronous event systems decouple tasks, admit an event, and let backend workers process their own piece. Please move ahead on. Then secure in the perimeter. Okay, fine. Having the operations performed, also being authenticated. Security is very much important and playing a very crucial role here. Right. Your credentials should be safe wherever they are, and also not allowed to be visible to any stranger it might be. Right. In this situation or in this context, you will have to understand how does it happen. The first one, authentication, it's a passport control. Suppose you're getting into the airport and you're trying to fly out abroad, right? Then it's passport control. That okay, he is a person entering into the airport. He has a passport. He has a proof that he is being authorized and he can move anywhere out of the country. In that sense, you are authenticated. That is verified identity, API keys, JWT tokens, OAuth. So if JWT tokens and OAuth are process or the methods lying under authentication, right? And then moving to authorization. Authorization is okay. Even if you are authenticated, that is, even if you are permitted or identified easily, you should be granted some permissions in order to perform some operations. So there comes the main role of authorization. And then rate limiting, restricting flow to prevent abuse. That is, if you are sending multiple requests, then it might be very difficult for the server to be handled. Right. So there you have to limit the number of requests so as to smooth execution of the process. Right. Then you might understand at a final sense that security is enforced at the gateway, isolating backend services from malicious traffic and DDoS attacks. So in order to prevent malicious attacks at the system, security has to be implemented. Please move ahead on. Then now we have learned about how is the request processed from the front end to the back end, how is the network managed and all. But what if the network has to be optimized? That in a sense, the accuracy of the network has to be improved, the efficiency of the network has to be improved. Then what all could be done? The first mechanism, catching layers. What do you mean by catching? As I told earlier, catching is nothing but storing the sessions or storing the data at multiple places, right? At multiple places, no matter where how much is the distance. But if the distance is very low, then the validation while authentication is very easy and uh, very fast. Seriously. And if it is a long distance, then has to travel through that distance, has to verify, and it's a very time taking process. So you might read out here: staggered catching layers serve requests from the nearest fastest memory, bypassing deeper backend service, right? And coming to mechanism two, that is payload compression. If the network has to be optimized, then whatever payload in the sense, the schema, the JSON format, what we have spoken about earlier, right? Payload compression, that having a JSON format, if it is very heavy, then it is very difficult to be processed, right? So in that sense, the size of the payload has to be compressed. And similarly, you can look into the picture displayed here, and also you can also find the context written there. Data is compressed during transmission to minimize bandwidth usage and accelerate delivery. Right. And then the third mechanism what could be implemented to optimize the network is that connection reuse. Suppose you are utilizing HTML, CSS, JavaScript to generate the front end, and you're trying to add some data again and again, right? And in order to see the changes in the front end, you will have to reload the connection again and then, I mean, again and again, and then you will be finding the modifications done in the front end. But what if the connections have to be reused? rather than creating new connections. Then you might utilize React.js, Next.js, and all technologies coming up in the front end, right? So why do we have to reuse the connections? Why not create a new connection? Suppose you are creating new connections, then having a lot of connections, it might be difficult to be handled, right? It might lead to a lot of server start and stop, right? So in order to handle them, the connections have to be reused rather than opening new connection or closing new connection. So you can find this here. Multiple requests travel over a single persistent HTTP by2 connection, eliminating the need for repeated handshakes. Please move ahead on. System immunity and reliability patterns. We will try to understand what is the immunity, or why the immunity has to be focused of a system, and what are the reliability patterns on which we can depend upon, right? First of all, we'll try to understand what are the symptoms, or what are the points to be focused where the system might get weak or not, right? The first symptom here we'll notice is endpoint is completely down. Suppose we have a URL, and at the endpoint, suppose we'll take an example. In the previous example, you are placing an order, and the URL is Amazon slash orders, right? There, the endpoint is orders, right? Suppose the endpoint is down, right? Imagine the endpoint is down, then the entire website is down, of course, right? Or partially, the endpoint separately might be done. So in that sense, in order to diagnose what is the issue, you will see cascading network collapse imminent. That is, even if a single part of the network is collapsed, then entire network may get collapsed. So that is the problem you might understand, or that is the problem related to the symptom. Then, how would you simply resolve the issue, resolve the problem? And that is very simple. You will have to stop calling the failing service immediately. That is, you will have to wait for some time, try to reload, and try to make the connection rather than running the connection immediately. Next, network is temporarily unstable. What if the network is temporarily unstable? Then how do you identify what is happening there, right? You will have to check out the packet logs or transient errors, what is happening with them and all. So how it could be solved? Simple. Automatically attempt the request again after a brief pause. Like you have done, you have done running the process again, but still you find that the issue is not solved at all. Then try to make multiple attempts. Might be at a point the server might get connected to the website, and it might run smoothly again, right? Then the third symptom, request is hanging indefinitely, right? If the request is hanging indefinitely, what could be done? What is the problem you have to identify? It might be a resource lock or person thread, right? In order to solve that, you will have to enforce a strict cutoff limit. Don't wait forever. That is, you need not show your patience, and you do not wait forever. Rather, implement a strict cutoff limit, right? And then next symptom, retry accidentally triggers twice. If you're running the connection for multiple times, sometimes it might trigger the website to be opening twice, or loading some errors. So in order to diagnose that, you will have to identify to duplicate state mutation. Now how it is done? How to resolve that? You have to design operations to yield the same result safely, even if repeated. That is, even if repetition is done, you will have to design operations such that the result is yielded safely. Please move ahead on. Now we'll understand in a realistic sense how is the process happening, what is the orchestration formula running here, right? The first method, that is the request. A user has entered into a, suppose we'll imagine the application to be some Ola service or Uber service, right? You're trying to place a ride, that you are willing to move somewhere, you want to travel somewhere, right? Then through the application, you will post a request that I'm looking for a ride, someone who can pick me up and drop me somewhere, right? You will post a write request, and then uh, it reaches to the API gateway, and it tries to locate the service. I mean, identify the location service, the pricing service, and displays on the application, right? And then the third one is the handoff. Then a write is requested. A write requested event drops into an async queue. Driver network alerted. That is, a driver notices that you have sent a request and this is the location, this is the price and all, right? And then the live update. In order to send that to the driver, the WebSockets are mainly utilized. As I told earlier, the WebSockets play a main role in communication, in chatting applications and all, chat space and all, actually. So in order to send the user request to the driver, right? There comes the use of WebSockets. So driver accepts persistent WebSocket connection, pushes live GPS coordinates, and hence your location is visible, and the price of what driver is asking is visible to the user clearly. So this is the orchestration process that usually happens in any booking service, or it might be any application. It is quite similar to this. Please move ahead, Pawan. Right. The fallacies of distributed computing. That is, we will be understanding what might be the fallbacks of distributed computing. I mean, computing. You can just have a glance about the slide actually, so that you will understand easily. The wire networks are fundamentally unreliable. Packets drop. That you can simply depend on any network. They are unreliable or not. They are not durable at all. So you'll have to make the other networks also uh, ready so as to face the error and so as to solve it. The next comes the clock. Latency is never zero and varies wildly across geographies, right? And then the ghost and the mirror similarly. Real architecture assumes failure is a constant, not an anomaly, right? Failure is a constant, not an anomaly. Please move ahead on. The loss of digital coordination. This is the overview of how coordination has to be done and all. The first one is APIs are contracts. Now that we have understood APIs play a role of intermediary, they also act like a contract. Elastic interfaces dictating protocol, format, and boundaries, not just endpoints. In the sense, they not only allow operations to be performed, rather, they also act as elastic interfaces, showcasing the protocol, format, and boundaries required. And then comes abstraction enables scale. Why abstraction enables scale? What is the meaning of it? Suppose there is a lot of complexity at the backend and it has to be hidden, and a simple process have to be performed so that the application runs smoothly. Right. In that sense, statelessness and decoupling allow systems to grow horizontally without limit. Right. And the next point comes architecture is always layered. Systems never communicate directly. Request traverse gateways, that is, travel through the gateways, balancers, and queues. And then failure is inevitable. Resilient systems utilize timeouts. That is, the rigid systems always utilize timeouts, circuit breakers, and idempotency to survive an inherently unreliable network. Right? To face an unreliable network, it is very important to maintain timeouts, circuit breakers, and idempotency. Right? Please move ahead on.
Done.
Yeah. Thank you.